Welcome to lesson 3.3 on the factor theorem. So when we work on the factor theorem, we're going to start sort of what we know with the remainder theorem and build on that. We looked at what happens if we divide a polynomial by x minus a, where a or x minus a is a factor of that polynomial. We saw that the remainder would be 0. And so if we sort of pull that together, what we can say is that the factor theorem tells us that x minus a is a factor of a polynomial p of x if and only if p of a is equal to 0. Now, if you haven't seen this before, IFF is if and only if. And what that means is sort of both directions of that statement have to be true if we can say if and only if. So if p of a is equal to 0, then x minus a is a factor of polynomial p of x. And if x minus a is a factor of polynomial p of x, then p of a has to be equal to 0. All right, so in order for the point at x equal a to satisfy p of a equals 0, a must be a factor of the constant in the term p of x. So that last term in whatever polynomial we have, that a naught or the a0, a has to be a factor of that. This is known as the integral zero theorem. Now, this only works when the leading coefficient, which we usually call an, is equal to 1. If it's not equal to 1, then we can divide by whatever an is, and we can pull that factor of an out of the polynomial, and then we can use the integral zero theorem. All right, so we're going to go back to our favorite function, our quadratic here, our x squared minus 5x plus 6, possible values of a that are factors of 6. And we have to make sure we check both the positive and the negative factors. And then we're going to use this factor theorem to find the factors of p of x equals x squared minus 5x plus 6. I should also note about the integral zero theorem. We're going to look at what's called the rational root theorem in our next lesson, and that takes care of how to find all factors if I have a non-1 coefficient of the x to the n terms. So if a to the n, or sorry, if an is not equal to 1, the rational root theorem will take over for us. And that's really the only theorem out of sort of the factor theorem and the integral zero theorem that I really need to know, but we need to build our way up to rational root theorem. Okay, so if I just slide back up here for a second, a has to be a factor of the constant term. That's where this piece comes from, the fact that I'm looking for factors of 6. So if I look for the factors of 6, I'm going to have plus or minus 1 and 6, plus or minus 2 and 3, right? 1 and 6, 2 and 3. And so I'm just going to put a plus or, I should put a plus or minus in front of all of them. I'll jam my signs in there because it is, all of those terms could be positive or negative. And so if I want to use the factum theorem to find the factors of p of x, well then, right, so remember, we're thinking about x minus a, and so we're going to try all the values of a. So I could try p of 1. So I'm going to put 1 in for x, so that gives me 1 minus 5 plus 6, so that's going to be 2. That's not a factor, which we already knew, but we're going to do this anyway. Let's do -1 first. So p of -1, so that's going to give me 1 plus 5 plus 6, so that gives me 12, so that's no good. P of 2, so I get 4 minus 10 plus 6. That's equal to 0. That means x minus 2 is a factor. All right, let's try -2. We've got, so 4 plus 10 plus 6, so that gives me 20, so that's no good. P of 3, so I'm going to get 9 minus 15 plus 6, that equals 0, which we already knew. So we're kind of I wouldn't say wasting our time, but we're going to prove to ourselves that the factor theorem is going to work here. P of negative 3 is going to be 9 plus 15 plus 6, which is going to be 30. And then we've got to do P of 6. And did I say P of 9? I should have said P of negative 3 is going to give us 30. P of 6, so we're going to get 36 minus 30 plus 6, so that's 12. And P of negative 6, so that's going to be 36 plus 30, so 66 plus 6 is 72. So we can see using the factor theorem that x minus 2 and x minus 3 are factors of our function p of x equals x squared minus 5x plus 6. Okay, so let's try this with a higher degree polynomial then. This time I'm not going to use the factor theorem to find all of the factors, but I'm just going to use the factor theorem to find a factor that I can then use to divide my function. So I'm going to divide, I'm going to fully factor x to the 4th minus 5x cubed plus 2x squared plus 20x minus 24. And so my steps are, I'm going to use the integral zero theorem to find a root. I don't need to find all of them, I need to find a root. Then I'm going to divide the polynomial by a binomial. And so I'm going to find a value of a here, and then I'm going to divide by x minus a. So I will get a binomial times a cubic. I will repeat that to get me a root of the cubic. I will divide again by a binomial. So the cubic that I found in step 2, I'll divide it by whatever new value of a that I find, where p of a equals 0. We'll call this p of x again, just so it's my polynomial. And then I'm going to, when I divide a cubic by a binomial, I'll get a quadratic, and then I'll just factor the quadratic using any method that I know. All right, so the first thing, we need factors of 24. Now, instead of listing them all, I'm going to start with the easy ones. The one that I know that's always going to work is going to be plus or minus 1. So if I think about p of 1, I've got 1 minus 5 plus 2. So we're at negative 4, negative 2, plus 20, and then minus 24. So that's not going to work. And if you want to, we can always just grab a calculator to help us with this. I don't need a graphing calculator for this, but I'm just doing 1 minus 5 plus 2 plus 20 minus 24. Right, so that gives us negative 6. So that's no good. What happens if we have negative 1? Okay, so negative 1 to the 4th is 1. Minus, that's going to give us negative 5. Negative 1 squared is going to be a positive 1 times 2, so that gives us 2. Minus 20 minus 24. Well, that's not going to work, is it? Okay, so let's move on then. So we had, now we should write these down while we're going so we don't forget them. So we've got negative 6 for p of 1, and we've got negative 36 for p of negative 1. Okay, that was negative 6. P of negative 1 is negative 36. We hope that we can get nice values early on. So we're going to have 2 and 12, we're going to have 3 and 8, and we're going to have 4 and 6. So let's try plus or minus 2. So let's try p of 2. So that's going to give us, so 2 to the 4th is going to be 16. Oops. Minus 40 plus 8 plus 40 minus 24. And there we go. P of 2 is equal to 0. I don't care about any of the other factors right now. I might come back and look for them in a couple of minutes. If I happen to find multiple factors, I can always use it because when I get so I've got a quartic here, right, a fourth degree polynomial. When I divide it by my binomial, I'm going to get a third degree polynomial. And any factors of the fourth degree polynomial will also be a factor of the third degree polynomial. Sometimes I get repeated factors too, but we'll see that as we go. So I am going to divide my p of x by my a is 2, right? So x minus 2 is a factor of that polynomial. That polynomial is 1, -5, 2, 20, -24. Now, because I'm fully factoring this, I'm assuming that the polynomial is factorable. It also tells me that my remainder better be 0 because I'm getting a factor here. Right? And we just saw, using the remainder theorem, we know that when a is equal to 2, the remainder is 0. All right, so 1 times 2 is 2. That gives me -3. 2 times -3 is -6. So that gives me -4. -4 times 2 is -8. That gives me 12. 2 times 12 is 24. And look at that, remainder is 0. So now I have p of x is equal to x minus 2 times x cubed minus 3x squared minus 4x plus 12. Okay, now I care about the cubic. I need to factor the cubic. I don't need to try 1 and -1 because 1 and -1 weren't factors of the quartic, so they're not going to be factors of the cubic, right? I'm going to find all the zeros here. I can save myself a little bit of time because I don't have to check. Well, actually, I can't save myself any time. I guess the only thing I don't have to check are factors of 24 because I know for the cubic, I'm looking for factors of 12 here. So let's keep going and let's now try p of -2 and see what we get. See if that's going to be another factor. So I need to scroll. Actually, do you know what? I'm going to just check. I'm going to write it down here. I'm only going to check the cubic. I could go back and check the quartic if I wanted to, but I just need to check the cubic at this stage. So let's see, what do we got? So we've got -2 cubed is going to be -8 minus 12. So -4 times -2 is going to be +8 plus 12. And I can see that I've got myself another factor. Now, if we have a graphing calculator, there's a nice way to cheat. We'll look at it at the end, but the graphing calculator can help us very easily find integral roots of any function. So what that means is I'm going to take my cubic and I want to divide it by x plus 2 or x minus -2. So my a value is -2. I've got 1, -3, -4, and 12 as my coefficients and constant. Bring the 1 down. -2 times 1 is -2. That gives me -5. -5 times -2 gives me a +10. -4 plus 10 is 6. -2 times 6 gives me -12. And there we go again. Our remainder is 0. And that leaves me with, go back to my green ink again, p of x is equal to x minus 2 times x plus 2 times x squared minus 5x plus 6. Well, look at that. Factors of that quadratic we already recognize. Factors of +6 that add to -5 are -2 and -3. So what I had started to mention a second ago, we're going to check our answer by using the calculator, and I'm just going to put that original function in here. So let me go back up here. Now, given that you're not going to have graphing calculators for your test, this isn't going to help us on our test, but it can help us when we're working on our homework to make sure that we're not missing something, or maybe to help us identify a mistake. So 20x minus 24. And what I'm going to actually look at is, instead of looking at the graph, I want to actually look at the data table. And I'm just going to look for integral values. Now, maybe I come back to my page and I look at the factors of whatever that constant were, so I know which values I have to look at. And remember, again, I know I didn't write this in here. I'm going to add it right now, I guess. But we're looking at positive and negative for all of these factors. I'm just looking for the values where I have a root, or where the function is equal to 0. So I can see that I have roots at -2, at 2, and at 3. Because it's a quartic, I might continue to scan to look for that 4th root. But of course, what we should see down here is that I have a double root. We'll talk about what that means next lesson in terms of the graph. In terms of the graph. But I could rewrite that function. So I have x minus 2 squared times x plus 2 times x minus 3. And that's what my fully functioned quartic function looks like. There is a Delta Math assignment for you to do, so make sure you do that before you come into your next class. And if you have any questions, have those ready.